Right, so now we're going to talk about this idea of the unit circle. So the unit circle is a circle with radius 1 centered at the origin. So if I look at some if I look at some terminal arm with angle theta, my radius here is going to be equal to 1. And so now if I look at the trig definitions of sine and cosine, I know that sine is equal to the opposite over the hypotenuse. Well, in this case, that's going to be y over 1. So in a unit circle, the sine value of theta is always going to be equal to the y coordinate. The cosine is adjacent over hypotenuse. In a unit circle, I'm going to get x over 1 because my hypotenuse is the radius, which is 1. So in a unit circle, the x coordinate will always give the cosine value. Tangent is opposite over adjacent, which in a unit circle is going to be the y over x value. Notice the y over x value is also going to be the slope of this line. So I can also think about what this means for properties for both sine and cosine. So domain, I'm going to think about all of my x values that are allowed. So notice that my x values are going to go between 1 and -1. What this means is that cosine theta is never going to be greater than 1, and it's never going to be less than -1. So my domain is between 1 and opposite way. So including -1 and 1. The range is my y values, same thing, -1 and 1. My period is when my values start to repeat. So notice that I'm going to go around the circle and I'm going to get all of my, if I'm thinking about my x values, going around the circle, I start at 1, get to 0, and then go to -1 before I start repeating. So my period for when my values are going to repeat, well, I'm going to end up with the same values between 180 degrees and 360 degrees for cosine, but my sine values are going to be different there. My sine values are going to be ranging from -1 up to 1 before they repeat, and that's going to go from -90 to +90. So my period for both sine and cosine, I don't end up making the full circle until I've done a full 360 rotation or a full 2 pi radians. So my period is 360 degrees or 2 pi radians, but noting that my values are going to repeat, I'm going to see each value twice. So for my x values, I'll see this x value twice. Similarly, I'll see this y value twice. So it takes 360 to make a full rotation, but in that full rotation, you see each sine and cosine value twice. We have tan theta, we saw up here is y over x, and we've seen many times before that sine over cosine also gives us tangent. So tan theta we can think of as sine theta over cos theta. The Pythagorean identity, well, if I look at my triangle and use Pythagorean theorem, I have x squared plus y squared equals r squared, but I know that the radius is 1 for my unit circle. X is the same as cosine of theta, so when I say cosine theta squared plus sine theta squared That's equal to 1. 1 squared, of course, is just 1. Another way to write cos theta squared is to write cos squared theta. So this means the whole cos theta value squared. So that's another way to write this. And those are my identities.